right, this part of the presentation is going to go over elements. You're going to want the elements portion of your graphic organizer, this portion right here. You're going to want that in front of you as we go through this PowerPoint. Okay? All right, so an element is a pure substance made of the same type of atoms. Everything in the world is made out of atoms, but an element, each element is its own kind of atom. Okay, so let me say that again. An element is a pure substance made out of the same type of atom. Elements are the smallest piece of matter and cannot be broken down into simpler substances, either by a chemical reaction or by pulling them apart. They are the smallest piece that you can get. Any smaller and it wouldn't be an atom anymore. Elements are represented by chemical symbols. These chemical symbols are arranged on the periodic table of the elements. Periodic table of the elements. Only elements will be found on this periodic table. So if you can't find it on this table, it's not an element. Some examples are oxygen. The element oxygen is represented with a capital O. Hydrogen is represented with a capital H. And neon is represented with a capital N and lowercase e. Those are some examples. Okay, there are rules, and all chemists around the world follow these rules for writing element symbols. First of all, they're all printed. The second rule is the first letter is always, 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 always a capital. Okay, rule 3 is if the element symbol is 2 letters, the first is always, always, always capital, and the second one is always, always, always lowercase. And an example here is a capital H, lowercase e for helium. Okay, so 2 letters, the first one is a capital, the second one is a lowercase. If an element happens to have 3 letters in its symbol, the first is still capital, the second and third are always lowercase. A compound is a pure substance made out of 2 or more elements in a set ratio. And I think that's why they can say it's pure, because to me, pure is one thing. But a compound always has the same ratio. So right here, you'll always find the compound water in the ratio 2 hydrogen to 1 oxygen. You won't find water any other way. Same with salt. Salt is in the ratio 1 sodium atom to 1 chlorine atom. You won't find anything else stuck in there. Otherwise, it's not salt. Okay, so it's a pure substance made of 2 or more different elements. Element is one kind of thing. A compound is 2 or more in a set ratio. Compounds, they can be broken down into simpler substances through chemical reactions. Some is harder to undo than others. Compounds have different properties than the elements that make them up. Once they bind together, they change into something new, kind of like water. The hydrogen is a gas, and oxygen is a gas, but when they're combined in a chemical reaction, it makes a liquid water. So 2 gases have one property, and it makes a liquid which has totally different properties. Okay, compounds have different properties than the elements that make them up. Compounds are represented by chemical formulas. Okay, some examples, H2O, H2O is a chemical formula for water. CO2 is the formula for carbon dioxide. NaCl is the formula for sodium chloride, which what we call salt. NaHCO3 is the formula for sodium bicarbonate, what we know as baking soda. Okay, now draw a Venn diagram on your next page, and we're going to compare elements and compounds. Remember, what is in common between elements and compounds goes in the middle. What's different goes on the outside. And label your circles. Which one is elements and which one is compounds.